So, continuing with complex numbers, square root property states that it is a property which states that if x squared equals a, then x equals plus or minus the square root of a. This helps us when we're solving. Now, a complex number, any number which can be written in the form of a plus bi, where a and b are real numbers, and I is the imaginary unit. So we have a real part, the a, and a complex part, bi. Or not just a complex part, an imaginary part, the bi. Complex conjugates, two complex numbers of the form a plus bi and a minus bi are complex conjugates. The key thing to note here is the only thing that changes between them is the operation in between the real and the imaginary part. If one's plus, the other has to be minus. That's the only part that changes. Now, when we're adding complex numbers, we combine like terms. So when you take a look at the example 1, 4 minus 7i plus negative 3 plus 10i, the 4 and the negative 3 are the real parts. 4 plus negative 3 is 1. The imaginary parts, negative 7i and 10i, are like terms. Negative 7 plus 10i is 3i. So 1 plus 3i is the result. Example 2, 5 and negative 2 are the real part. 5 plus negative 2 is 3. The imaginary parts, I and negative I. 1 plus negative 1 is 0i. So that just simplifies to 3. Subtraction, same thing. Combine like terms. But first, it helps if we rewrite the subtraction, distribute that subtraction. So 17 minus 8i minus the quantity 2 minus 9i turns into 17 minus 8i minus 2 plus 9i. 17 and minus 2 are the real part. 17 minus 2 is 15. Negative 8i and 9i are the imaginary part. Negative 8 plus 9 is 1i. Okay. On negative 6 plus 12i minus the quantity 1/4 plus 3/4 I. Can rewrite as negative 6 plus 12i minus 1/4 minus 3/4 I. Negative 6 and minus 1/4 are like terms. Negative 6 is 24/4, so negative 24/4 minus 1/4 is negative 25/4. 12i minus 3/4 I. Well, 12 is 48/4 minus 3 is 45/4, so plus 45/4i. Now, the next part, multiplication, well, we can use the distributive property, we can use FOIL, or we can use the box method. Remember, FOIL is just an acronym for the box method. And here we're just going to use the FOIL method or distributive property on both of these. So negative 3i times 11 is negative 33i. Negative 3i times minus 2i is plus 6i squared. I squared is negative 1. And 6 times negative 1 is negative 6. So that gets us negative 6 minus 33i. 4 minus 5i times 6 plus 7i. Well, 4 times 6 is 24. And, of course, put it in standard form. 4 times 6 is 24. 4 times 7i is 28. Negative 5i times 6 is negative 30i. Negative 5i times 7i is negative 35i squared. 28 minus 30 is negative 2i. And here, negative 35 times I squared is negative 35 times negative 1. Negative 35 times negative 1 is positive 35. 24 plus 35 is 59. So 59 minus 2i would be our end result. So let's try some solving. When we solve, we want to get the x squared by itself. So we start off with, first, just subtract 100 from both sides. That gets us 4x squared equals negative 100 divided by 4. That gets us x squared equals negative 25. And then take the square root of both sides. And whenever we take a square root when we're solving, we have to list both possible answers, the positive and the negative. And when we take the square root of negative 25, that's going to get us plus or minus 5i. X squared plus 4, subtract the 4 from both sides. Take the square root of both sides, and that gets us x equals plus or minus 2i. Now take a moment, pause the video, and go ahead and try number 12 and 13 on your own. Okay, so number 12, subtract 20 from both sides, divide both sides by 5, and then take the square root of both sides, but the square root of negative 4 we know is plus or minus 2i. Next part, subtract 64 from both sides, take the square root of both sides, and we end up with x equals plus or minus 8i. Adding, subtracting, multiplying. So adding negative 2 plus 5i plus 1 minus 7i. Well, let's put the real parts together, negative 2 plus 1, and the imaginary 5i plus negative 7i. So negative 2 plus 1 is negative 1, 5i minus 7i is negative 2i, and we're done. Multiplying, it helps, here I'm just going to use the box method to help us out. So get our box, 2 by 2, 1 plus 2i across the top, 1 minus 2i down the front. 1 times 1 is 1. 1 times 2i is 2i. Negative 2i times 1 is negative 2i. Negative 2i times positive 2i is negative 4i squared. We can simplify that. We've got 1, the 2i and the minus 2i cancel, and then that's going to be minus 4 times negative 1. That gets us 1 plus 4, which is just 5. So pause the video for a moment. Try the 16 and 17 on your own. Okay, so negative 3 plus I minus 2 minus 8i. Well, let's first distribute the subtraction. So negative 3 plus I minus 2 plus 8i. Negative 3 and minus 2 are like terms. I and 8i are like terms. I'm just grouping them. So that gets us negative 5 plus 9i. 17, again, the box method. So negative 6 minus I across the top. 3 minus 3i down the front. 3 times negative 6 is negative 18. 3 times negative I is negative 3i. Negative 3i times negative 6 is positive 18i. And negative 3i times negative I is positive 3i squared. Simplifying, let's see, the 18i and negative 3i are like terms, so that's going to get us 15i. So negative 18 plus 15i plus 3 times negative 1, because that's what I squared happens to be. Let's see. That ends up simplifying to negative 18 minus 3 plus 15i. So negative 18 minus 3 is negative 21. So that simplifies just to negative 21 plus 15i. Okay. Now go ahead and try the next set of numbers on our worksheet. Which would be number 5, 6, 7, 9, and 10. So 5, 6, 7, 9, and 10. So 5 through 10, just not number 8.